This is RD Sharma Solution, Class 12, Chapter 9, Continuity. Exercise is 9.2. Find the points of discontinuity, if any, of the following function. This fx is given when x is not equal to 2 and when x is equal to 2. The point of contention or checking is 2. So x equals 2. When you go on the left or right of that point, x equals 2, then we have to use this function x raised 4 minus 16 by x minus 2. The value of the function at 2, that is f2, is 16. So in order to discuss the continuity and discontinuity, first of all, we have to see that x4 minus 16, this is a polynomial function. The x minus 2, again a first degree polynomial function. And since both are polynomial function, fx by gx, the division is also a continuous function. Okay. So we have to, this denominator, we can do what? We can simplify it so that we can go ahead with the checking of LHL and RHL, that is left hand limit and right hand limit. So let us first of all simplify it. X raised 4 minus 16 it is. So we can write it as 2 raised 4. Denominator we have x minus 2. So x square whole square minus 2 square whole square. So I am doing the numerator. So it can be written as a square minus b square. So a minus b, a plus b. So x square minus 2 square into x square plus 2 square. Okay. Now this can also be written as a minus b, a plus b. So x minus 2 into x plus 2. And then we have x square plus 2 square, that is 4 you can write. In the denominator, we have x minus 2. So you can cancel these x minus 2. Now finally we have x plus 2 into x square plus 4. So this is also a polynomial, and multiplication of two polynomial will always be continuous function, as we have discussed in theory. So let us take the LHL and RHL. In LHL, because the point of checking is x equals 2. So 2 minus h we have to use here. X equals 2 minus h. On the right hand side we will use x equals 2 plus h. Okay. So let us put this value in x plus 2, x square plus 4. So I am putting 2 minus h on the left hand side, LHL. Same thing, but here we are going to put 2 plus h here. So 2 plus h and plus 2. And this x square plus 4, so 2 plus h whole square plus 4. Okay. Now, either you open it and put h equals 0, or you can put h equals to 0 directly here only. So what do you get? 2 and 2 are 4. This is 2 square plus 4, that is 8. 8 4 is 32. Limit h tends to 0. Here also we have 2 and 2, so 4. And then you have this h as 0, so 4 plus 4, that is 8. So 32 on both the sides. That is fine. But the thing is that LHL, RHL, when we talk about, the value of the function at x equals 2 is 16, not 32. Find the points of discontinuity, if any, of the following functions. This is given when x is less than 0, it is sin x by x. When it is x greater than or equal to 0, it is 2x plus 3. So what do we have here? We have the sin x. Sin x, we know that it is continuous everywhere. X is also continuous everywhere. X is, you can call it as an identity function, or you can call it as a first order polynomial as well. So fx by gx, when you have fx and gx separately, they are continuous everywhere. When you divide them, then also they are continuous. 2x plus 3 is a straight line, is a first order polynomial. So this is also continuous. So this discussion you can write here. First thing you have to write in solving these type of questions. Then the second step is to find out the actual continuity or discontinuity at x equals 0. So At left we'll take 0 minus h, right we'll take 0 plus h. So we'll use this sin x by x. So here we'll use sin minus h by minus h. Here we are going to use what? This is h, so 2h plus 3. Sin minus theta is minus sin theta, so you can write minus sin h divided by minus h. So just cancel these minus out, 2h plus 3 here. Okay, let us apply limit h tends to 0 on both the sides. Sin theta by theta is 1. 2 into 0 is of course 0, so you get 1. So LHL and RHL are not equal. They are themselves not equal. Right? If you want to find out the value also, that is f0, just put x as 0 in this 2x plus 3. So 2 into 0 plus 3, what do you get? You get a 3. Okay. So what do you see? They are not equal. All three should be equal. So it is discontinuous at x equals 0. Find the points of discontinuity if any of the following function. Now same discussion here. X is 0 is the point of discussion or contention, and since at x equal to 0 already 4 is there, sin 3x is a sine function, so it is continuous everywhere. X is again an identity function, or you can call it as a first order derivative, first order polynomial also. So they both are separately continuous, and if you take the quotient, that is fx by gx, they also will give you the same result. And the value which is constant 4, which is actually a line parallel to x-axis. So let us take 0 minus h and 0 plus h on LHL and RHL, and this sin 3 in place of h x I am putting minus h. Here right hand side again in place of this x I am putting h. So sin minus theta is minus sin theta. So this is minus sin 3h divided by h. So you have to introduce a 3 here. Multiply numerator denominator by 3. Sin theta by theta. This is sin theta by theta, and it is going to be 1. Limit theta tends to 0, or h in this case h tends to 0. So you have 3 and 3 on both the sides. That is LHL and RHL are equal. But the point is that x equals to 0, at x equals to 0, the value of 0 at the fx at 0 is 4. It is not matching with LHL and RHL. So it is not continuous. Discontinuous at x equals 0. Find the points of discontinuity if any of the following function. So this also we are going to do in the same way. Just remember, when we have various functions which are continuous by itself, and when we combine them, say in the form of division, in the form of addition, in the form of multiplication, they will still remain continuous, as we discussed in theory. Sin x is continuous, x is continuous, sin x by x is continuous. When you add two continuous functions, that is cos x and sin x by x, in turn they will also be continuous. Okay? So when you add them, cos x and sin x by themselves are continuous. So assume these two separate functions, or you can call it three functions, fx, gx, and you can say rx, sin x, x, and cos x. So they all are continuous by themselves. Along with this 5 is also continuous because it is a straight line which is parallel to x-axis, right? So remember, fx equals 5, that is y equals 5, is simply a line which is parallel, and that will always be continuous. A straight line is always continuous. There is no break. So this all you can write. The way of writing I showed you here on the left. And we need to check for the continuity as well. So at x equals 0 we have to check. It is already given that the value of the function at x equals 0 is 5. We go left, we go right. So when we go left, we have to put 0 minus h. Right, we will put 0 plus h. Okay. So this is sin minus h. I am replacing x by minus h. Plus cos minus h. On right hand side, you don't have to do anything. It will always be 5. Okay. No. It will be sin h by h plus cos h. I am so sorry. I changed my sentence. So both sides just put minus h and h. So sin minus theta is minus sin theta divided by minus h plus cos. Cos minus theta is plus cos theta. So what do you see? Right hand side and left hand side, they both are equal. They are same. Sin h by h plus cos h, both the sides. Apply the limit. Limit h tends to 0. What do you get? This is sin theta by theta, which is going to be 1. And cos 0, that is cos 0 is 1. So 1 plus 1. So both the sides will get 2. LHN and RHL you will get 2. Okay. But the value of the function at x equal to 0 in this question is given as 5. So they are not matching. So fx is discontinuous at x equals to 0. Hence the only point of discontinuity for this function fx is x equals 0. Okay. So when we combine, see, separately the functions can be continuous by themselves, but when we combine them, then we need to see how they turn out to be. Again, the points of discontinuity for this function, fx equals, there is a proper function given when x is not equal to 0, and since tan inverse x is there, tan x is continuous not everywhere but at a domain. Sin x and cos x, they are continuous everywhere. Tan x is not continuous everywhere. It is continuous at particular domain. This need to be very clear. The polynomial function, of course, the numerator is continuous everywhere. Okay. But tan inverse x, when we talk about the domain, since we know that sin inverse x, for example, minus 1 and 1, that is the domain of it. So when we take fx by gx, don't worry about anything about tan inverse x, because tan inverse x cannot be 0 when we talk about fx by gx. P by q form, q should not be equal to 0. That is the only point we discuss. So tan inverse x, it should not be equal to 0. That is the only thing. Okay. But now talking about the continuity or discontinuity, the process is same. There is no difference which we already, in the past we have done. We will check at 0 minus h, 0 plus h, x equal to 0. 0 minus h, 0 plus h, so x at x equal to 0 is already given as 10, so f0 is 10. Okay. So whether you get the value LHL and RHL equals to 10, that will decide the continuity and discontinuity. So x equals 0 minus h I am giving, x equals 0 plus h I am giving these values. So x raised 4, so minus h to the power, this is minus h only, this is plus h. Minus h to the power 4 plus h to the power minus h to the power cube plus 2 minus h to the power square. Now whatever you do here, I am doing it, you are also watching. But the thing is, the numerator is always h. There is always h. There is no h in the denominator to cancel it out as well. So it will always be 0. Whether you place anything, you take something common, try to cancel it out, whatever you do. This is right hand side I am doing, that is the LHL I am doing. I am putting h. Left hand side we place minus h. Okay. Now you see this tan inverse minus h or plus h, whatever you do. On the right hand side you have to put plus h. So that is a correction here. So when you put h equals 0, it will be 0. Numerator, h is 0. H is always there. So as I said, the denominator, don't worry about that. The numerator itself is saying 0. Okay. And tan inverse h divided by h, if you even want to go further, tan inverse h divided by h, that is going to be 1. So apply the limit in the denominator, introduce a h, try to cancel a h in the numerator, but that is not going to affect, because still we have h cube plus h square plus h in the numerator. Okay. So what I am trying to suggest here is tan inverse h by h, of course when you apply the limit in the denominator it is going to be 1. But numerator will always be 0. So left hand side and right hand side both will be 0. And what is the value of the function at 0? It is 10. So that is discontinuity. Find the points of discontinuity, if any, for the following functions. Now discontinuity or continuity, first we need to know that what are the functions being given in the question. The question is saying e to the power x minus 1. But we know that e to the power x minus 1, this e to the power x by itself is continuous. Log x is by itself continuous. They both functions are continuous. E to the power x, e to the power x, log x, all these are continuous. But when we divide them, they will also be continuous because it is p by q form. But the value of the function at x equal to 0 is 7. So whether the limit of this function is matching with 7, that will decide the continuity or discontinuity of this function at x equals 0. Okay. So we'll apply a direct limit. Don't worry about LHL and RHL here, because you'll see what will happen. E to the power x minus 1. Now e to the power x minus 1 divided by x, limit x tends to 0 is 1. We have already seen in many questions. So e to the power x minus 1 by x, multiply numerator denominator by x, introducing x. Log 1 plus 2x. So log 1 plus theta divided by theta, limit theta tends to 0 is 1. That also we have seen. Or you can call log 1 plus k by k, limit k tends to 0. Okay, this is also 1. So introduce a 2x, introduce 2x in numerator denominator. Now just apply the limit. So when you apply the limit, e to the power x minus 1 by x and log 1 plus 2x by x, both are going to be 1. This is 1, this is 1. X gets cancelled, you get 1 by 2. Okay. So this is 1 by 2 is the value of the function at limit x tends to 0. But what is the value of the function at x equal to 0? It is 7. F0 is 7. It is not matching with half. So this given function is discontinuous at x equal to 0 and it is continuous everywhere. Okay, this will take in the next discussion. Till then, thank you so much. Take care of yourself.